And we are live. Hi, everybody. Welcome to Developers Let's Code. Um, Sorry, a bit of feedback there. So welcome. This is Developers Let's Code. I'll be kicking off in a minute. So the episode today is all around the CDK, and I'm going to build a serverless application using the CDK. It's all going to be live coding today. So we're actually going to code for the majority of the episode. So I'm looking forward to some of your help with debugging live on chat, which will be great. And we'll see how we go over time. So I just need to pull up the chat because my chat's not showing. There we go. So there'll be natural breaks in today's chat, so please shout out, say hi. I am currently sitting in my study in Perth, Western Australia. So say hi, say where you're from. And also I'm interested today in what sort of language you develop in, because as we'll see with the CDK, it's got a lot of different languages that it supports. Hey, MAG. I can nearly say that's you need more vowels in that name. So yeah, so say hi, and we'll get stuck in probably now. So it's just turned past the hour, so we'll get into a bit of an introduction into the topic, why we think it's important, and what we're going to do with it today. So when we think about, hey John, when we think about the CDK, we need to take a step back and think about infrastructure as code. So what is infrastructure as code, and why do we use it as developers to help build our native cloud apps? So when we were, if we step back 10 years and think about how we were provisioning environments, whether it be dev, staging, production, what we had to do, we would automate a process if we were lucky of logging into the actual box that run the application, and we would run some scripts. Sometimes those scripts may go awry and actually stuff our environment up, so we couldn't get a representative environment. It was very hard to get a representative environment for applications to run in. So then if we move on in evolution for a little bit, we then had a more declarative style of provisioning those environments using things like CloudFormation or Terraform. And what they do is they enable us to define what the environment looks like. And we define it as YAML files or as JSON files. And we could put those files in source control, and that way we can be quite confident that when we build in dev will be representative of what we do in test and also in production. The problem there is if you've ever seen a JSON CloudFormation file or YAML file, it's quite long and it's quite verbose. And I'll show you one today as we go through this coding exercise. But things like brackets in the wrong place if you're working in JSON, or YAML in particular if you get a space in the wrong place, can be quite frustrating. And as a developer, I don't really think that they are it's not a code language per se, and I prefer to write the scripts in the coding language of my choice. So enter the CDK, the AWS Cloud Development Kit that we're going to talk about today. What this does, it allows us to actually specify our environments, how they are provisioned and what runs on them using code. So before we begin, just a little three things to take away today if you're interested in the CDK, or how the CDK is actually structured. So here, and this is the diagram I'm showing above my head today. This defines, and this is what a typical CDK application looks like. There's three levels or layers of abstraction in the CDK. There's the top level abstraction, which is the application. We call it the application. Inside the application, we have one or many stacks. So the stacks themselves are made up of what we call constructs or resources. Some people call them resources, but they're constructs. And what a construct is a combination of services that go together to do a thing. So it's a nice way of abstracting out our applications, and that's what the CDK is. And then once we've defined our application using stacks and constructs, we can then generate the necessary CloudFormation script that we then use to provision our backend environment. So that's the CDK. That's a little bit of background about it. And no, John. So just answering the question from John, is the CDK only used for serverless apps? No. So the CDK is used for anything you can provision in AWS, and I'll show you the documentation and how you can do different things with the CDK as well as serverless. So let's jump into a code. So I'm going to do all today's coding in AWS Cloud9. If you're interested in Cloud9, you can provision one in your AWS environment. But the first thing I'm going to do is make sure that I've got CDK installed, CDK version. So I have got version 1.62 of the CDK installed, which is the latest version. If you didn't have the CDK installed, you can quickly jump into the documentation. So this is the documentation page. It shows you how to install the CDK. It's a simple npm install globally. It also shows you what currently languages are supported. So TypeScript, I'm going to build today's demo in TypeScript. There's also JavaScript, Python, Java, and C Sharp. All of those are supported. And then there's also an API reference. I might jump up into this a few times during today's show. And the API reference tells you all the different things you can provision, Amplify, MQ, all of the things and services you can provision using CDK. So there you go, John. There's the other services that you can provision. And as you can see, there is quite a large list of services. Okay, that's a bit of background, and I just have a look and start coding. Okay, so I'll just clear out this. So the first thing I need to do, I need to create an area to build my app in. So I'll just make a little directory. I'll call it, what do I call it? Serverless web app. That's what I'm going to build. And CDK serverless web app. So that way I've created my directory, I'm in it. The next thing I need to do is initialize the CDK. So and the way I do that CDK, I run all my commands with the CDK, and then I go init, and then the CDK needs a type. So as I said before, you can have an app or a construct. The app is the overlying wrapper of everything. So that's what we're building today. So I have an app. And then I also have to specify a language when I'm initializing on my project. So the language today is TypeScript. And that way, that will initialize the local app. So you'll see on the left-hand side, the directory structure will start to pop up. So what the CDK init actually does, it initializes not only the folder structure, it creates a local Git repository for you, so you can keep all of your things very nicely version controlled, and then push them up to a shared Git repository later to share them. And so there we go. We've got there's our Git folder. We've got a few other folders. We've got sort of package JSON, typically what you see in a TypeScript package. So just to check that everything is working okay, I'll do npm build. So make sure that the init has worked correctly, and that should tick. So everything's good, everything's fine. The next thing I need to do is do the Bootstrap command. So the Bootstrap command for the CDK is a way to connect in my local environment to the cloud environment that I'll be building in. So that's the cloud environment and the what region I'm going to be building in. So that's all bootstrapped. So we have, in essence, initialized and bootstrapped the CDK, and we're ready to start coding. So all of the code for the TypeScript version of the CDK is in serverless web app stack. So if I open that up, you will see that there's some scaffolding there that we can just define the class. It extends stack, and it got some constructor got a constructor as well. So what I'm going to do is start filling in that with the code. So my code that I'm going to build is going to go in this area here. And but what we've got to think about is what we're going to build. So we're going to build a serverless app. So we're going to have Lambda, little consume requests that come from API gateway, and eventually we're going to get some additional lambdas listening on resources on the API gateway to persist stuff in DynamoDB. So the first thing I'm going to build is that lambda. So I go back into my command line, and we need to install the lambda dependency. So if I go npm, I go install, I go AWS, which is the library name, cdk slash lambda, which I always spell wrong for some reason. Then that will pull down lambda, and it should stick it in, what have I spelled wrong, slash AWS dash lambda. So that's the name of the package. I was being lazy there. I forgot the AWS dash. So that'll pull it in, and what you'll see is it's pulled it in, didn't it? Yes. Yeah. Cool. And it should be in package.js, and I just want to check that. It pulled it in okay, and we've got the right version. So here's the version of the CDK that I installed, and there's the version of the Lambda that I've just pulled in. So I'm happy with that. Just a word of warning, when you're working with the CDK, just make sure that those dependencies are the same versions. That will stop any potential errors occurring and mismatches of versions which can happen. So just a word of warning there. So I've installed my dependency, so that's imported into this class. So I import star as, so this is a lambda from the package I just installed, which is AWS CDK slash serverless lambda, like so. So now I've got the class imported. Let's start using it. And so we define a let's define a welcome lambda. So something that will return a 200 and some text if I hit it. So just define it as a welcome lambda. And let's see. So we need to construct it. So that's a new lambda instance. So it's a function. So all of these constructs are all part of the library. I'll pass in this. So if you notice, this is the scope. So how we tie different constructs together is by passing the scope around. So if you think about it as the bucket that all the constructs live in. So that's why we push this into this construct. Give it a name. So hello, hello. And then I'm going to define some properties. Let's do that properly. Skip that. So in here, I'm going to define some properties of the Lambda. So with any Lambda, you need a runtime. So I'll define a runtime Lambda, and this is all nicely typed for you. So you can go node, pick the right runtime. I'll pick the most recent version of Node. And then next, I'm going to go, where does the code for the Lambda exist? So you can get, define the code for the Lambda. I'll show you where you can get it from. You can either define it locally. I using it from asset, but you can all, which I'm going to do. But you also can get it from a bucket. You can inline it as well into the code in CDK. And so for this one, I'm going to use from asset. And I'm going to define a directory in this directory structure called Lambda, which I'll do in a minute. And then I need to define handler inside the Lambda. So if you haven't used Lambda before, it's a fairly straightforward definition that you have to do, where every Lambda function that you define needs a name, and inside the name is the handler method. So that's what I've just defined there. So that's our first welcome Lambda that we defined. So just to go, we've imported the Lambda function, we have written some code that defines it. And then we need to, the next thing we need to do is actually define the code that this Lambda is. So what I'm going to do here is create a new folder. I'm going to call it Lambda so that my code can find it. In that Lambda folder, where did it go? There it is. I'm going to create a new file. Yep. And obviously the file name itself will be called hello because that's where it's expecting my handler to live. It'll be called hello.js. Now in the so this is the actual function itself. So Lambda functions define the handler. If you haven't written one, I'll just write one quickly for you now. So it's async. So it's an asynchronous call, like all lambdas are. It takes in one argument, which is the event. And then from the event, I'm just going to log something to the console. Let's go log. Let's go. Let's just push capture the request as it comes in. So we just go request some text that defines a request, and then I'm just going to stringify, which is a JSON library method. I'm going to stringify the event that comes in. Otherwise, it's going to be undefined and two spaces. So that's a nice little way of outputting events in JSON. And then I'm going to return status code, status code. It's going to be 200 because it's successful. And header values. So minimum header values I'll need is probably I'll need content type, which is a capital T and a dash for memory. Yep, content type, and I will need it to be the text. So it's defining I want this returned, what type. So that status goes headers, and then finally the body. So the body, I don't know, it's just going to say something. Hello from devs, let's go Cdk. And a new line. Okay, so that should be it. I'll just kill that, and that's just for. So that's our Lambda function. We're keeping it in a taking an event. We're outputting the event, and then we're ready some text. That should be it. So let's go back to our console and go empty and run it. So let's to deploy, build our stack. Like so, no, that will build our Lambda function. Make sure everything's compiling okay. The next thing we want to do, and this is something I'm going to show you about the CDK. We can go CDK synth. So I like doing this, especially when I'm demoing the CDK, because what it does, it synthesizes the CloudFormation template that you would output. So why do I do this? Because if we go back to our code, we can see that our code to generate the CloudFormation template is 12 lines long, but the actual CloudFormation template, which lives in CDK out service web stack here, and this is a typical, so if you haven't seen a CloudFormation template before, this is what one looks like. And what we see here is how our function is defined, and all the handlers defined, version of node. And so that's 111 lines of CloudFormation that you'd have to define if you wanted to do the equivalent thing in CloudFormation. So just think of the brackets and spaces you'd have to define with that. So I always have a little bit think of it as a bit smug that CDK is a lot more efficient. So that's the synth command, which you can do to test out and have a look at your CloudFormation. The other command, the next command I'm going to run with CDK is Cdk deploy. So this will push that CloudFormation template up into my environment and will provision that Lambda function. it will first ask me to, am I sure I want to deploy the change? I'll go yes. I'll show you later how to get around that prompt. But that will start then deploying that CloudFormation template. So while that's doing, I'll look at the chat. Support anything in the lines of pre-compiling binary dependencies like Zappa. I'm not sure, Garnlink. Python deployment tool for Lambda. So pre-compiling binary dependencies. That's something I haven't come across, Gamelark. But it's not to say that CDK won't be able to do that. I'd have to check and get back to you maybe. Don't know the. Do you think the hot dog is a sandwich? It's not a sandwich. It's not between two pieces of bread. So, yep, good questions from the chat there. So what's happening is so we're deploying here. We're doing our pre-compiling. Yep, exactly. And then so that's it compiled, and then we've also got the ARN of the resource that's been created. So if I wanted to have a look at that resource, I could go into my friendly AWS console. I could go to Lambda there, and you will see that it will be there at sometime. It'll be the 12. Yeah, there we go. That's it there. And that's our Lambda. If we can jump into it. There's our code. Hello from the devs. Let's code CDK. So you'll see the Lambda is being deployed, and then it's done. So that's a Lambda. But what can we do? We need to start triggering the Lambda to get it to evoke the Lambda from the event. So the next thing I'm going to build is that RESTful API, that API gateway that will facade this Lambda and connect up to it. So I'll show you. You'll feel there's a real pattern emerging here in terms of how you build out applications with the CDK. So the next thing I'm going to install is the API gateway component. So I do it the same way. So I go npm install AWS CDK, and it's all AWS.API gateway. So that will then install that dependency into my node packages, and I will have cool. So that's that installed, and now we need to go back into our stack, and we need to define then the API and how that's going to work. Again, we need to import it into our stack. Let's start, and we'll call this API gateway from AWS CDK / AWS gateway. Okay, and now once I've done that, I need to then, like I did with the Lambda, define it as const. I'll call it API, and again, let's new it up. So it's API with, and I'm defining a REST API here. So here's all the methods you can do. I'm going to build a REST API. Again, I'm passing in this scope and giving it a name. Hello. So that's it defined. I'll then add an integration point. So the integration point is how I'm going to wire up this API with the Lambda. So I'll call it API hello integration, and it's going to be, again, I'll move it up. It's API dot Lambda, yeah, Lambda integration. And the name of the Lambda is, yep, welcome Lambda, defined, welcome Lambda, I've defined above. And then finally, I'm going to add that resource, so the path. So we go const API hello. Oop. Then this is the API root, and then add the resource. This is obviously the path you call in the API, and we'll call this one hello. Hello. Yep. And then what we do, we need to add that, so that resource, we need to add the method. So API hello, add, oops, add method. This is going to be a get. Okay, it's going to be a get. It's going to write to the hello integration. So those 4 lines of code are basically saying define a new API gateway. Um, in that API gateway, have an integration point to Lambda. What called the Lambda is /hello, and it'll be called as an HTTP GET request. So that's all that code is doing. So let's just make sure it compiles. I like doing this. Build. Okay. Yep. Again, let's see how many lines of cloud formation that would have created if we were to do this. I don't want to say the old-fashioned way, but using cloud formation. So here's our generated stack. So as you can see, we're getting a lot bigger now. Once we add an API, we've got 375 lines of cloud formation, or the equivalent to 19 lines of CDK TypeScript code. So let's deploy that up and see what it looks like. So while it's deploying, does CDK provide functionality to deploy handlers within TypeScript without having to manually run TSC? So handlers within TypeScript without having to manually run TSC. I'm not sure the question there is Windows 10 update. You can inject handlers inside the CDK TypeScript files yourself. So I showed you the from asset command here. You don't have to use that. You can pull it and inject the TypeScript or the handler inside here itself if you want to. I'm just doing it and externalizing those to show you a good example of how you can do that. Yeah, thanks again, Lark. It is. This is. So I've been using CDK for a while now, and it's such an easy and concise way of building things. From a developer perspective, it's really nice. I didn't like CloudFormation YAML at all. I found it very tedious, especially the space thing and the bracket thing. Even when we're using tools like lint, I just found it tedious. I don't view it as a proper programming language. Whereas this is, and the fact you get the choice as well is pretty awesome. So I forgot my yes. While we're doing that, let me show you how you can get around that the prompt. So if you want to deploy, you can actually, without that approval, you can go require approval and go never. So that will then negate that yes no challenge for you. Thanks. Yeah, thanks, David. I should be paying more attention to the compiling. I haven't tried. Can Lambda Hello TSB a thing? I haven't tried, to be honest. Windows 10. I have been writing CDK primarily in .NET, so TS is not my first language. I'd probably give it a try and see what happened. To be honest. Cool. So we're waiting for that. So let's see. Let's just look at the reference. I find the documentation says a lot about the service, and the documentation for the CDK is very good. So if we look inside the TypeScript documentation, you can see that all of the packages that are there. So we were using, so you can use API Gateway and V2 as well. We were using API Gateway, so we can just drill into things that we can use and what sort of props. So the props element you could have injected when you're constructing API Gateway. And you can show, I can go into what sort of properties are available. So I find myself more often than not, coming back to the CDK documentation. So that's that. So now we've got our API, we've got our endpoint, and we can. I just want to copy that into a browser. As it's a GET request, I can put it into a browser, and our resource from memory was below. Yep. So I think that you can see that text. So that worked. So we got our provisioned our API gateway. We've provisioned our code on it, and the Lambda is firing, and we've got a result. So that was pretty easy. Not gonna lie. For if you've anybody in the chat who's provisioned that sort of REST API and a Lambda or a mechanism to consume the request, that usually takes longer than 15 minutes. So and also it's recreatable, so I can push this into Git and I could share it with my team, or I could actually provision and create a construct, and I could share it on as an npm library, so that and call it Derek's API with Lambda that says hello or something like that. So again, that's a great way we can share these constructs around, as well as use the constructs that have been built by AWS. What I didn't mention, and I probably should have at the start, was the CDK is all open source. So there's a great community around the CDK, um, which actually which is all here. So if you're interested in helping with CDK, it's all here. You can how to be a contributor, everything like that. It's very cool. And really, again, as developers, we like fast feedback cycles. I think the whole open source around CDK, also AWS Amplify, really great way as developers to really take control of the product and help get that fast feedback cycle happening. So that's our first start into the CDK. So we've got our API and our Lambda. So the next part and next level of complexity is we're going to add a persistence layer. So as this is a serverless app, the place to add that persistence is using DynamoDB. So let's go and see what that looks like with the CDK. So we're back into our command line, and yep, we have been employing and seeing the pattern emerging. The first thing we want to do is install the service that and the libraries for the service that we're going to use. So again, it's all adhering to naming convention. It's called AWS Dynamo DB. Boom. I'll bring it down into our packages. And then the next stage is let's go and import it into our TypeScript file, so into our stack. We'll start as, I'm just going to call it DynamoDB because it makes sense. From at AWS CDK slash Dynamo. There you are. So we've imported it. So the first thing we want to do, because we're using a persistence mechanism, is in Dynamo is build a table. So we need somewhere for the data to go. So let's again define it as a const, define it as a very imaginatively titled table, and new it up. New, so imported it, use it as that. It's a table. Again, we've got other things we can do. We're going to buy a table, refresh it in the scope. Let's call it, just give it a name, people. Why not? And then just add some props. So table props that we need from Dynamo. So if you're familiar with Dynamo, you need at least one partition key. So I'm going to create that. I'm going to give it a name. That's again my imagination running wild at the minute. Type is what type? So it's, again, this is defined as a library. It's so if I'm a name field, I probably want to be a attribute type string. Yeah, it's a name field. And then the table name itself, I believe. No, I haven't closed that. That's not right. Hold on. Name, string. Yep. Close it. Yeah, there we go. Table name. We're going to call the users table. Okay, that's our table defined. So now we've got our table. What do we need to do? So a table in Dynamo is great, but we need to actually write data to that table. And at the minute, we've got no mechanism to do that. It's just a table. It's just going to be sitting there. So we need to write some CRUD operations to that table. So we need to define some lambdas and a mechanism to write to that table. So let's go and do that. So we'll leave our lambda welcome lambda. It's just almost like a health check that we're going to use for our API. Just tidy that up a bit and start writing a well, a write lambda or a create lambda. So again, this will be very similar to this last lambda, which will be the welcome lambda. So as I'm a lazy developer, I'm going to do the old copy pasta and call it create. And I'm sure you don't want to see me slowly type every lambda that we're going to build today. Again, this is a lambda function. It's going to have a name. So what are we going to call it? Create handler. Same type. Runtime code is going to be, so it's still going to be in the lambda directory. But we need a something else. We need an environment. This environment variable is something that will pull from the environment, and it will where we're going to introduce the table name. So the environment variable will be called table name. Yep. What we're going to need. We have a table defined, which is the users table. Yeah, I call it users table. Yep. Table name. That's not right. This is a colon. It's called users table. And maybe one of those. And the handler for this one will be called create. Oh, that's our create lambda. But then, as well as the create lambda, we need an integration point, like we did for the last one. So again, I'm going to do the old copy pasta. I'm going to. This one is the API I've already defined, so I don't need this again. Yep, we just need a create. Oh, come on. just need a create integration. And it'll be Lambda integration, and we're integrating with our create Lambda, yep. And the API itself will be called create. And the resource, you can see the pattern of my code design emerging here. So that's the create. I need to add the method. So obviously it's not going to get be a get. It's going to be a post because we're adding, we're posting some data up, and that's that. So let's just check our create lambda. I haven't made a mistake here. So the create lambda itself is a constant. It's a lambda function. It's called the create handler. It's taking a node 12 runtime. It is coming from the asset folder lambda. The environment I'm going to pass in is going to be table name, and the table is called, at this particular junction, we're using the users table. Handler is going to be create user handler, and const API create integration, lambda integration, API create, blah, 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 blah. Yep, it's good. And then, as well as a create lambda, I also need somewhere to read the table to make sure that my create lambda has worked. So I'm going to actually duplicate this code for the most part, but I'm going to build a little read lambda. Yeah, let's do it the same way. So again, this is a read lambda. Lambda function is going to be called read. Runtime's the same. Lambda folder is the same. User table is the same. It's going to be called read user handler, like so. So that's the lambda function, and then the integration will be called the read integration point. Be integrating with the read lambda. So it's going to be API read. This is where I should have done search and replace, but that would have been even more tricky. Read. So and the integration is the post. It's actually going to be a get this time because I'm reading capitals, and API read, like so. Okay, that should go like that, and that is the function defined. The next thing and the last thing I need to do, so what I've done, I've got my table defined, I have got my two operations defined on the table, so the create lambda and the read lambda. The only problem is, and the last thing to do is set up some sort of access control so that the lambdas can actually access the DynamoDB table that I've set up. So if I was to do this in CloudFormation, this would be a lot of work. However, in CDK, I can go table grant is a number of grants that are already set up against the table. So I'm going to go grant read data. Who you can read from the table? My read lambda. Well, that's interesting. Right? Read lambda can read from the table, and then the other grant I need to set up is my read write, and that's going to go to the create lambda. Saved, and so that is my CDK defined. So I'll just pause for a second and go to questions before I write the handlers. But the next thing, I probably won't write the handlers. I'm just looking at time. I've got them saved somewhere. I'll look them up. I just want to make sure I'm not missing anything in the chat. Yep, so Michael Humsey, in CloudFormation you can remove the stack and all resources. So at the end I'll show you how to do a CDK destroy, which does exactly the same thing. Um, Jason Smith, a secret uses a secret when building the RDS instance. Not off the top of my head, Jason. I don't know where that is. But if you, so what I've done in the past, if I come across a particular use case that I'm interested in, I look at the particular package repositories for the libraries I'm going to use. So if I'm using C Sharp for instance, then somebody could have uploaded something that does that to NuGet, and similar npm for JavaScript and TypeScript. Oh, David's already answered the questions. Thanks, David. um, Line 46, line 35 and 46. Thank you very much, Windows 10 update. I missed that one. Awesome. Thank you very much. Yep, you're absolutely right. You have it right. Thank you, David. It should be called my API hello. It's not correct. So it needs to be called API create, obviously, for this one. I love chat debugging. It's my favorite type of debugging. It's almost have a live linters. And there, API create da, da, dogs. What happened there? Don't know. Bo, bo, bo. Right, go and API rate. And that's the joys of copy and pasting, as we all know. The time you may save by copy and pasting are all sometimes overwritten with silly mistakes. So we then go and start defining our handlers. So the handlers themselves, I've got to read and write. So again, new file. I've got to call this one. This is called read. Yeah, read user. Read user.js. I'm going to open it up. I've got the. I don't want to see me. Nobody wants to see me type this, so I will grab it. I'll quickly walk through it. So again, we're using the AWS SDK as a way to connect into the table. We're defining a process environment, which is the environment table name we'll pass in. We'll pass in the region. And then from that, we will define from the event that actually executes the handler, we will grab the name from the query string, which is the table name, and then we will call into the table, and that will we'll actually read from the table. That's all it's doing. And then the other one we need to write is the create read create. File. Did that work? Nope. We file create user. Yes. Again, very similar. So this is where is it? There. Let's open it up. Create user. So again, using the AWS SDK, pushing in the table name and the region. We're going to pull out from the table. We're going to push into the table three fields: name, location, and age. We're going to push these through as parameters, and then it's going to persist. Otherwise, we get a few errors. And that is that. Again, a lot. The handlers themselves are pretty straightforward. Read and write into Dynamo. So if you're familiar with Lambda interacting with Dynamo, you've probably seen this pattern many times before. Okay, so that's the handlers. I've got my yeah, that's my CDK defined. Let's just clear that out a bit. And npm and build. Okay, so let's copy pasting worked okay. Yeah. Okay, so it's compiled. So it looks like it's compiled. So again, CDK then let's see what sort of size of CloudFormation template we'll be looking at. were we to do this? Um, let's have a look. CDK out. The asset is this one. Reload it. We got it open. So we are looking at. We're going to hit 1,000. Oh, 980 lines of JSON. Yay, not 1,000 yet. So 50 lines of code, nearly 1,000 lines. Another thing that I haven't mentioned about the CDK is a cool little feature, is the ability to go CDK Diff. So CDK Diff, what that will do, it will look at your current stack as it's deployed into AWS, and it will look at your local stack that you're thinking about deploying, and it'll do a diff between the two. And it will output that diff like so. So all this is doing is saying, oh, I'm adding the following Lambda functions, the following methods to my API gateway, all added, and it's changing a few things as well. And so that's what Cdk Diff does. So if you're, say, inheriting a project as a developer and you're connecting to an environment that exists and you want to know that everything's in sync before you start maybe building something, adding something into your stack, yeah, CDK Diff is a nice way of going, yep, we're both on the same page, so we can start developing. So that's CDK Diff. And so let's deploy this stack and see if it works. CDK deploy. And I won't miss the prompt this time. Um, thank you. So this will then deploy the stack up. So I might take a minute or so. I'll just grab a quick coffee break. So what will happen? It'll generate the cloud formation and push it up. Another interesting part of the CDK, and just maybe the missing piece in where everything is it actually creates a bucket that stores the templates. So if I go to S3, you'll have a CDK bucket here that is there. So there, if you look at that, that's where the CloudFormation goes when you go do a CDK deploy. It'll go into that staging bucket um, when it needs it. And also, if you look at CloudFormation itself, so that's what the Bootstrap and Bootstrap does. And then here we have our serverless web app stack, and this is the typical what you see if you were using CloudFormation, JSON or YAML to push your stack updates. But as we can see, this is what's happening. We've got our updated progress, and you can see how things are going there. That's that. Other things I wanted to show you. I love this little green this bar that's telling me how far along things are. But other things I wanted to show you. There is an awesome CDK workshop if you want to get started. I'll show you where that is now. Ba, ba, ba. Is it here? Yeah. So this is cdkworkshop.com. I'll put it in the chat here. It's an awesome place. It is great because you can choose your language and it'll push you through the same use case for each language. So so for my case, for example, my Python skills are very poor, not as strong as say my .NET and Java. So if I wanted to learn CDK and Python, I could use the equivalent commands and see how they looked in Python. That's cool. Again, this is a great place to start. The other thing I want to show you as well was there was this little website called Play with CDK, which I found this week. So this enables you to start building out your stack and parts of your CDK, the resources of your CDK without actually installing the CDK locally or anything like that. So it'll almost do a lint on your thing, and it'll synth the code that you've written and output the CloudFormation as a result. So it's a good way if you want to try new things and stuff like that without going through the trouble of installing the CDK locally or anything like that. Does so Chicken's Life, does the CDK generate a CloudFormation template for you? So um, so the CDK generates its CloudFormation, but you'll see it is here's the CloudFormation here, Chicken's Life. So if you go to CDK out, you can see that the stack that is generated is CloudFormation. So it is all CloudFormation. It generates for you. Okay, so that is now deployed. So let's go and test it. So I'm just going to grab the URL. So when I test things, I use a tool called Postman. Here it is here. So Postman, it's an easier, I find it easier to visualize stuff. So what I'm going to do is, the URL for Playground. Sorry, Mike. Let me get that for you now. It's here. It's play with CDK.com. Oh. So what we're going to do, we're going to do a post. So if you remember our resources was create. And what we're going to do, we're going to create, I think it's name, if I can still remember it. We had location as well, Perth, and my age is give or take 100. So if I send that up, oh, we have a 200. So that means that it has persisted. We can check that. Let's go to, where's my console? There. Let's go to Dynamo. And we can see my table, users table, items. There we go, Derek 100 location, and so that's good. And I can then also test my read. What was my read API called? It was a get read. I think it was that. I think it was that. Yeah, let's see. Key, get name, and did I go with this? Lowercase Derek. Send that. Yay! So that read lambda works as well. First time. Wow. So yep, that worked well. So that's how you can say you can build our API and our persistence layer into our table. The next thing I'm going to do, and the final thing I'm going to do, is show you how to provision different types of stacks. So when I talked earlier, I talked about you have a dev environment, you have your test environment, and your prod environment. How would that look if I did that with the CDK? So I'm going to destroy my current environment. So CDK destroy, which will get rid of all um, the current setup. And that was a question that was asked earlier. So it'll delete all the resources I've provisioned, but obviously I've still got the code and everything here. So I can provision it again. So that is that. So that while that's destroying, let's go about how we define different stacks for different environments. So before I was in the lib directory where we defined our stack. The entry point to the CDK is actually in the bin directory where we have this TypeScript file, which actually calls our application and our stack that we've been developing in previously. So obviously in here, we can start thinking about how we can define multiple stacks. So I'm going to do that now. So I'm just going to keep my app. Obviously that's my entry point. And I'm going to find a new type of stack. I'm going to call it the So it's still our stack we defined, passing in our app. But I'm going to start thinking about what sort of environment this is. So prod, um, and now some props for prod. Say that's true, and give it, for example, if we wanted to do different regions, I could define different environments. So environment, boom, and give it a region. And so here I could go. So I'm currently in Southeast 2, and that's like that. And then if I wanted to define a second one, I could. I could go, boom. I could go, this is staging as an example. No, without a space. Prod false. I'll just keep the same region for now, but you get the idea. So this is not compiling because I haven't defined an interface in my stack. So let's quickly go in and do that. So this is my serverless web app stack. So I need to define an interface where it defines prod. So let's do that here. Interface. We'll call it stack props, something like that. So it extends CDK stacks, CDK stack props, CDK stack props, stack props. There we go. Oh, stack props. Don't go away. There. And then inside here, I need to go in this interface. I'm going to have a value called a field called prod, and it needs a Boolean value. So that's my interface defined. I then just need to remember that instead of my constructor using CDK stack props, I actually need to use this new interface and stack props to inject the environment. So that's good. And then next we need to do is define what those environments look like. So I would go again. I've got a whole list of stuff I can define. I've got this over here. So I can define those stack props. I'm just running out of time, unfortunately. Stack props, and then I can start pushing in my table name. So if I had my table name, for example, if I've got my table here, my users table, I could start then defining my read-write capacity as Dynamo DB write, which is defined here. And so that would provision a different type depending on the environment that I passed in. I could also, do stuff like billing mode. I've also got a billing mode here somewhere. I haven't defined that, but I could go Dynamo DB dot billing mode. You go provisioned. That's provisioned capacity, and then in my welcome lambda, I could do stuff like codes here. What sort of reserved concurrency I could use? So these are all levers that you can pull on Lambda and Dynamo, and this concurrency I think is passed in as well. Yep. So reserve 5, that one, and like that. And then for my REST API, some other lambdas, my create lambda, I could go again lambda, reserve concurrency, currency field, which is that. I can then environment itself. I can pass in my lambda vars, which will define all of the environments, and then go through that, and then finally my read lambda. Again, same sort of thing. So I go let's remember to concurrency, HTTP concurrency, and our environment will be passed in from Lambda Functions. A lot easier. Bo, bo, bo. Yep. So that should then do that. So that is using the different. Let's go. Let's see if it compiles or anything. Cool. So that's compiled, and then we can go CDK deploy. Probably run out of time to deploy this, but what will happen is it will create. Oh, it'll show you. So I've done this wrong. So now we can see that the changes that I've done are actually taking effect. So I need to, when I'm doing CDK deploy, I need to define a environment to deploy it to. So if I deploy it to prod, it will start here, go to prod, push through into here, use the props if props prod, define a table name called prod CDK users. The API gateway name will be that, and provision that like that. And likewise, if I wanted to define a staging environment, I could do the same. I could go CDK deploy staging. So we're running out of time. Unfortunately, I could spend a lot more time on this, a lot more time. So the resources I've put already are all there. If you need more, just reach out on Twitter or LinkedIn. I'm happy to help point you in the right direction in terms of building stuff with the CDK. As I say, start with the workshop. I'll put the link in the chat. Really great place to start, and the documentation is awesome. My table, you see, just before you go, the table um, didn't create because the people table already existed. Now that's because when you go CDK destroy, it won't remove the DynamoDB table as default. You have to actually specify that because we don't want to kill your data. So that's why that failed. Well, thanks very much for everybody for listening. My name's Derek, live coding via chat. So yeah, thanks very much, and I'll see you next time on Developers Let's Code.